G'day folks, today we're going to look at fractional indices. What's a fractional indice? Well, an index is a power. So we've obviously come across the powers before. Earlier in the chapter we looked at some of the more basic index laws. So remember, this one is the very first one that we saw. A to the power of n a to the power of n times a to the power of m was a to the power of n plus m. We added the powers. Okay? I hope you remember why this rule works. It's not just an arbitrary rule that some mathematician made up. It's because we know that if we say, for example, 3 times 3, well, we know that that means 3 squared. Okay, well, what's 3? Well, 3 is 3 to the power of 1. Times 3 to the power of 1 is 3 to the power of 2. So if I have 3 times 3 times 3 times 3 times 3, well, that's 3 to the power of 1 times 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 3 to the power of 1. If I count up all of those, there are 5 of them. That's 3 to the power of 5. But look at these two factors there. 3 times 3 is 3 squared, and those 3 factors there, 3 times 3 times 3 is 3 cubed, and the answer is 3 to the power of 5. Look at what's happened to the powers. When we multiply, we add powers. That's where this index law comes from. Now that's always true. When you multiply, you add powers. Okay? So keeping that in mind, have a look at what happens when we use a power that's a fraction. Okay, so if I talk about, for example, 3 to the power of a half times 3 to the power of a half. Well, the index law tells us that when we multiply, we add powers. Okay, so this would be 3 to the power of, well, a half plus a half is 1 whole. So it's just 3 to the power of 1, or 3. Okay, well, what does it mean then to say that this thing multiplied by itself is equal to 3? What's this thing? So a number multiplied by itself equals 3. Well, we've got a name for that. We call it the square root. So think about the square root of 16. The square root of 16, I'm asking, what number multiplied by itself will equal 16? Well, 4, right? 4 times 4 is 16. The square root of 16 is 4. Because 4 times 4 is 16. This number multiplied by itself is equal to 16. That means that 4 is the square root of 16. Okay. So that means if 3 to the half times 3 to the half equals 3, well, that means that 3 to the half is the square root of 3. Let me go over that again. If 4 times 4 is 16, that means that 4 is the square root of 16. 4 times 4 is 16, so 4 is the square root of 16. 3 to the power of a half times 3 to the power of a half equals 3. That means that 3 to the power of a half is the square root of 3. 3 to the power of a half is the square root of 3. Well, we can write that. We can say that 3 to the power of a half equals the square root of 3. And if you followed up to this point here, well, congratulations, you get exactly what's going to come up with the first part of our index law involving fractional powers. Okay, so the first part of our index law says this: if I've got a to the power of 1 on n, a to the power of 1 on n, well, that's going to equal the nth root of a. So let me expand this out. So I'll do an example. It's not just square roots. let's say, if I come along and I say that 2 times 2 times 2 times 2 times 2 is 32. Okay. In other words, the number that I multiply by itself 5 times to equal 32 is 2. So that would make 2 would be the 5th root of 32. The 5th root of 32, because I need to multiply by itself 5 times to get 32. Okay. So the way I would write so 2 is the 5th root of 32. If I, hang on a second, I'll just give myself some room. I'm just panicking because I'm running out of board space here. So let me go back. Because 2 to the power of 5 is 32, then I say that 2 is the 5th root of 32, or 32 to the power of 1/5 equals 2. Well, why do I know that? Because 32 to the 1/5 times 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 32 to the 1/5 equals 32 to the power of 1, because I add all of my powers together, right? A fifth plus a fifth plus a fifth plus a fifth plus a fifth, 5/5 is 1 whole. It's 32 to the power of 1. But I know that 2 times 2 times 2 times 2 times 2 is 32. So 32 to the power of 5 to the power of a fifth, times 32 to the power of a fifth times 32 equals 32. Well, that means that 2 and 32 to the 1/5 must be equal. In other words, 32 to the power of 1/5 is the 5th root of 32, and it equals 2. So what do we do with that? Well, we can express that. We can sort of stick that into a rule or a law, if you like, and that law is what I had up before. A to the power of 1 on n is the nth root of A. So, for example, 8 to the power of 1/3 is the cubed root of 8. Okay. If you're thinking about it, the cubed root of 8, what number multiplied by itself 3 times equals 8? 1 can equal 2. 2 times 2 times 2 equals 8. Okay. Or the cubed root of 27. 27 to the power of 1/3 is the cubed root of 27, which equals 3. 3 times 3 times 3 is 27. Okay. So here's the first part of our fractional index law. That's the first bit. There's another bit that comes along. What happens if I don't have a 1 in my numerator? What happens if I've got some other number? Well, let's have a think about that. I just said that 8 to the power of 1/3 was the cubed root of 32. Goodness gracious me. I just said 8 to the power of 1/3 was the cubed root of 8, and that was 2. Well, what if I get 8 to the power of 1/3 times 8 to the power of 1/3, and I just do 2 of them? Well, what's that? Well, that's 8 to the power of 2/3. Because remember, the rule is I just add my powers. When I'm multiplying things with the same base, I just add the powers. Okay, but what is 8 to the power of 1/3? Well, it's the cube root of 8, but what is the cube root of 8? Well, that's 2 times 2. Well, 2 times 2 is 2 squared. Okay, so looking at these two, we should be able to see how we can tease this out. Now look, it might take a bit of a suspension of disbelief on your part. In other words, you might have to accept what I'm saying for a little while until you've done enough examples, and then the penny drops and then you'll see it for yourself. But let me show you the algebra behind what I'm about to do. If I talk about 2/3, well, there's more than one way to get 2/3. I can go 1/3 plus 1/3, and that'll give me 2/3. But I can also go 1/3 times 2, and that'll give me 2/3. Both will work, okay? So when I write 2/3, I can just as easily write that as 8 to the power of 1/3 times 2. Okay, but what's 8 to the power of 1/3? Well, we know that. That's the cubed root of A. Of 8, sorry. That's the cubed root of 8 to the power of 2. It's the cubed root of 8 to the power of 2. And in fact, this gives us the skeleton for our full-grown version, which is the baby version of fractional indices. The full-grown version says this: if I have a to the power of m over n, that's the nth root of a to the power of m. Okay. Now, it doesn't matter if your power of m is outside the square root sign or inside. So what do I mean by that? Let me show you. Okay, so here is the index law that I'm going to be working with. So as an example, if I have 27 to the power of 2/3. Okay, well, according to this index law, it's the cubed root, it's the denominator, it's that root of 27 squared. Well, the cubed root of 27, we've already seen that. The cubed root of 27 is 3. So that's 3 squared, so that equals 9. Okay, but I could have just as easily, I've told you that I could have the squared inside. Okay, so just to not embarrass myself by making a silly mistake, if I had it on the inside, if I said that that was equal to the cubed root of 27 squared, well, that means that I need to get 27 squared, which is 729. So I'm up to the cubed root of 729. And if I ask my calculator, hey calculator, what is the cubed root? And Mr. Obeid should put his glasses on when he looks at his new calculator because he can't actually read the thing. 729. Well, there you go. You can see the cubed root of 729 is 9. So it doesn't matter which way we apply the index law. The power can be done last or the power can be done first. It doesn't matter which way. But the index law that we want to come away with is this: a to the power of m over n is the nth root of a to the power of m. It looks like a really, really nasty index law. It's actually a very straightforward one, very, very easy one to use. Okay, 2h. Sorry, guys. Okay, 2i. So exercise 2i gets us to work through looking at fractional powers. And it asks us to do a lot of this work without a calculator. I'd like you to actually try that without a calculator. You should know some basic square roots. If you're desperate and you're stuck, then okay, you can use a calculator, but then please look at why that answer makes sense. Don't just trust your calculator. Okay, think about why the answer the calculator gives you is making sense. I'm looking at some of the questions in that exercise. I would like to have a go at question 10. I'll do 10A and 10K. Okay, so this is exercise 2i. I'm going to do 10A and 10K. So 10a asks me to simplify the square root of 25s to the power of 4. Okay, well, what does square root mean? We know that now. We know that the square root means to the power of a half. We also know that if we've got the square root of a number times something else, then we can separate that surd out. So you remember, for example, if we had the square root of 4 times 3, that was the square root of 4 times the square root of 3. So if there's two things that are being multiplied, we can break our surd up. So that's what I'm going to do here. So I've got the square root of 25, and I've got the square root of s to the power of 4. Okay. Well, square root of 25, I should know, that's 5. Well, the square root of s to the power, square root means to the power of a half. Okay, if we think about our law in reverse, now think about what a square root means. So square root is just we don't write the 2 in there, it's understood that if we just have that symbol, we mean the square root. Square root of a, with m being 1, would be a to the power of 1 over 2. So square root is to the power of a half. So that means that this thing here is s to the power of 4 to the power of a half. Remember what the index law tells you to do when you've got powers around a bracket. You just multiply those powers. So it's 5s, 4 times a half is 2, 5s squared. That's 10a simplified. Okay. Now 10k, I think I said was the next one I'd do. That's 32 x to the power of 10, y to the power of 15. All to the power of 1/5. Okay, well, just like a surd, like a square root means we got the square root of this and the square root of that. It's exactly the same here when we've got powers, the power of a fifth. So it's 32 to the power of a fifth times x to the power of 10 to the power of a fifth times y to the power of 15 to the power of a fifth. Well, to the power of a fifth means the fifth root. We've already seen what the fifth root of 32 is. Okay, 32 to the power of 1/5, the fifth root of 32 is 2. And then what do we do with the powers around the bracket? We multiply them. 10 times 1/5 is 2. That's x to the power of 2. 15 times 1/5 is 3. That's y to the power of 3. And that's 10k done. Okay. Don't go straight to question 10. Start at question 1. Okay, and sort of patiently work your way through. You might need to come back and watch the video a couple of times. But if you've got any questions at all about exercise 2i there, then you know what to do. Shoot me over some questions. Thanks, guys.